All right, this is the 2019 question 6 on the FRQs. We're looking at the Taylor polynomials problem. A function f has derivatives of all orders. The portion of the graph is showed above, along with the tangent line at x equals 0, and derivatives are shown on the table above. So this would be the second derivative here, the value of the third derivative, the value of the fourth derivative. Okay, so let's remember what a Taylor polynomial is. They want us to write the third degree Taylor polynomial about x equals 0. Remember, about x equals 0 means that it's centered at 0, and that's where all of our information is coming from. Remember, Taylor polynomials are exact where they're centered, and there are approximations everywhere else. So if I want a third degree Taylor polynomial, which we usually call P3 or T3, the 3 is meaning the degree 3, that is going to be the function where it's centered, plus the first derivative, the first power, the second derivative, the second power divided by 2 factorial, and then lastly, the third derivative, the third power, the third factorial. So now we just got to look for our information. So f of 0. F of 0 is where the graph is crossing x equals 0. So we know that f of 0 is equal to 3. So far we have P3 is equal to 3. The next thing we look at is that we have f prime. Remember, f prime is the slope of the tangent line. So if we're starting here, our slope is going to be down 2 over 1, so negative 2. The next thing we need is the second derivative. Now the second derivative is concavity. I can't really look at the graph and tell you exactly what it is. I know it's positive because it's concave up, but I know my second derivative is 3. And then lastly, we need the third derivative because it asks us for the third degree Taylor polynomial. So there's a third derivative. So there is our P3 Taylor polynomial for that approximating function. Write the first 3 terms and the non-zero terms for e to the x. Write the second degree Taylor polynomial of e to the x times f of x. So the first thing it asks us to do is write down the first 3 non-zero terms of e to the x. Remember, e to the x, everybody shows up and everybody's positive. Now what they want us to do is multiply these. So I'm just going to write this down here. So I have e to the x. Oops, not e to the x. I meant to write the polynomial for e to the x. So 1 plus x squared over 2 factorial. And then we're going to multiply it by the P3. And they want us to multiply and get the second degree Taylor polynomial. Now it's impossible to multiply an infinite polynomial by an infinite polynomial, so what we're going to do is terms by terms. So the first thing I'm going to ask, is there any way we can get a constant by multiplying these 2 polynomials? The only way we can get a constant is by multiplying the 2 constants, so 3. Now we finished off the constant term. Now we're going to move on to the linear term. So how many different ways can we get a linear? So if I take 1 and multiply it by 2x, that's going to give us a linear. If we take x and multiply it by 3, that's going to give us a linear. So I'm going to collect the coefficients in front. So I would have negative 2 plus 3, and that's in front of our linear terms. Now we got to figure out how many different ways we can get a quadratic. So quadratics, we're going to take all of them and try to get the x squared. So the first way I can do it is I can get 1, and I can multiply it all the way over here. So the coefficient in front of that would be 3/2. And again, this is all of our ones for x squared. The next thing we can do, this was x, sorry, it got deleted. So x times negative 2x is also going to give us a quadratic. And then also right here, if I take this one times this one, which is plus 3/2, that's also going to give us a linear. So this is our possible, this is our value for e to the x times f of x. So this right here would be the polynomial they want. So 3 plus x plus 9/2 minus 2x squared. So that is our polynomial for e to the x times f of x. So part C, let h be a function divided by that integral. Use the Taylor polynomial found in part A to approximate h of 1. So the first thing we're going to need to do is integrate. So the polynomial found in part A. So part A, we had that polynomial. So all we're going to do is integrate that polynomial term by term. So the first term is 3. So we integrate that, we get 3x. Integrating minus 2x, you get negative x squared. Plus 3x cubed over 3 times 2, which is 6. And then the last one, minus 23/2, and this is now going to go x to the 4th, and it's going to be 4 times 3 factorial. So that's the exact polynomial we used in part A, and we integrated each piece. So now all we need to do is plug in 1. So h of 1 is approximately equal to 3 minus 1 plus 3/6 minus 23, 2 times 4 times 3 factorial. Part D. It is known that the Maclaurin series for h converges to h of x for all real numbers. What that means is that it has an infinite radius convergence, which we should have known that 1 was in the interval of convergence before we actually plugged it in. They should have told us that before that point. It is also known that the individual terms of the series of h1 alternate in sign and decrease in absolute value to 0. What that means is that it is a convergent alternating series. So right there, that means it's a convergent alternating series. Use the alternating series error bound to show that the approximation found in part C differs from h of 1 by at most 0.45. So for a convergent alternating series, the error is less than the first omitted term. Okay, so we know the error is going to be less than that first omitted term, which would have been the 4th degree term. Okay, so we know it's less than absolute value, that first omitted term. So we got to figure out exactly what that first omitted term is. We have to go back to our original problem because we only had up to x cubed. So the first thing I'm going to do is find out what the fourth term is going to look like, or the degree 4 term. So plus, that's going to be 54 x to the 4th over 4 factorial. But then we were asked to integrate that term before we got to the next piece. So going over here, now we got to really take this one. So that's my degree 4, so now I'm going to integrate that. So that would be 54 x to the 5th, 5 times 4 factorial. And we're going to plug in 1. So this is going to be 54 times 1 to the 5th over 5 times 4 factorial, which is 4 times 3 times 2, so 24. And I believe that's less than 0.45.